Hello guys, in this video I'm going to show you how to graph a system of linear inequalities and two variable. So things to remember here is that first of all you have to check to see the inequality sign here, symbol. In this case it's less than, so it's a strict inequality. It's exclusive. You have to exclude the values, the ordered pairs on the line. So you're gonna have to use dash line for this inequality here. Here you're gonna have to use solid lines because it's inclusive. So first thing you do, you just need to get a couple of ordered pairs points to graph the line. So in this case here, I'm gonna get, I'll use the y and x intercept just to graph. So you could choose any type of point you want, but for this problem, I'm gonna just use x and y intercept. So in this case, let's get the x intercept, meaning that y will be 0. And if y is 0, we'll get x equals to 1 because I replace y by its value, which is 0. So x is 1, therefore the ordered pair will be 1, 0, right? And you can get again a y-intercept. Now for the y-intercept, you're gonna let x be 0, okay? And if x is 0, I'm going to replace x by its value up there. So I'll have negative y equals to 1. Then dividing both sides by negative 1 or multiplying by negative 1, you'll get y equals to negative 1, okay? So the ordered pair here will be 0, negative 1. Okay, this is the second ordered pair. So the first one is, as I said, 1, 0. Second one is, which is the y-intercept, is 0, negative 1. Okay, so this is the first two ordered pairs. We can actually plot them to graph the line. So as you can see, we can go 1, 0, which will be here. So 1, 0 and 0, negative 1. 0, negative 1, I'll put it here. So I can draw the first line. Remember, it's a dashed line. Okay, so I'll draw a dashed line through the point. Okay, like this. Now a dashed line again, because it's less than, there's no equal here. All right, it's exclusive. All right, so now let's check the other one. For the other one, we just need, again, I'm gonna do x and y intercept. So I'll say x intercept. And for that, I'll let y be 0. And for that, y will be 0, so this will be cancelled out. So it will be 2x equals to 12. Therefore, x, divide both sides by 2, x will be 6, okay? So the ordered pair here will be 6, 0. Then x, y-intercept now. So I'll let x be 0 in this case. Now when x is 0, I'll have to replace x by its value. This term here will be gone, so it will be 3y equals to 12. Then I divide both sides by 3, and y is 4 because I divide both sides by 3. Okay, so the ordered pair in this case will be 0, 4. So 2 points, 6, 0 and 0, 4. Now we can just plot them. Okay, so we just plot those. Remember, it's a solid line. So 6, 0, 6, 0 will be, this is 2, 3, 4, 5, I'll put 6, 0 right here. And 0, 4, 0, 4, 1, 2, 3, 4. All right, so 4, 6, and this was negative 1, this is 1. Okay, so then I need to join them, right? I need to join the points. So let's join them with this line here. This is not perfect. All right, this one is better. Let me just erase a little bit. Okay, so like this, a solid line. as you can see here. Now, where do I shade? Which one is where is the solution really? Okay, well, when you have something like these two here, you have to test to see where, use a test point to know where to shade, right? So for the first one here, let's call this number 1. Let's call this 2. So if I test for 1 here, let's say I'm testing the 0, point, or the pair, right? 0, right here, the origin, because it's not on the line. So when I test that, and also I'm gonna test 0, for 2 as well. When I test it for the first one, up here, so I'll get 0 plus, minus 0 is less than 1. Is it true that 0 is less than 1? Okay, yes, it's true, 0 is less than 1. So since 0 is less than 1, that means the shaded region here will be where the 0, this point I'm testing where it is, because this part is true in this case. Okay, so if it's true, this is where I shade this side of the line. Well, this is how you do it. Okay, now since I have 2 lines, I need to know where to shade for the blue line, right? So let's check. For the blue line, I'm gonna test, and I'll say, okay, if I'm testing 0, as well, and I get 2 times 0 is 0, so I'll have 0 plus 0 greater than or equal to 12. Now, is it true that 0 is greater than or equal to 12? Now, this is false. 0 is less than 12. So, this point now will be false for this line here. So, this part now is now false. I put it in blue for the blue line. So now, since it's false, I'm going to shade away from it, the other side of the line. So right here. Okay. And you can, do this as well. But where the solution is where they meet together. So where you see the two shaded region where they meet together. So that means the solution will consist only of this area here, because these, if you want, you can erase anyhow, but they're not part of the solution. Okay, so this is what you do. This is how you get solutions for how you graph system of linear inequalities, I'm saying. Okay, so this is it. You erase. So the shaded region up there is the only region where the solution is. Okay, now one other thing to remember is that this point right here, you have to make sure you use an open circle on it, because it's not part of the solution. Okay, remember, it's not one line is solid, the other line is shaded, so where they meet would not be part of the solution. Okay, now remember that. Okay, so this is how you graph a system of linear inequalities and 2 variables. Okay, very easy. You just need to make sure you graph each linear inequality separately, and you just choose the shaded region where both of the shaded region where they actually intersect. Okay, so that will be the solution, and that will be the graph of the system of linear inequality. Okay, thank you.